Hello guys. So today we will discuss about Wheatstone bridge. So how to solve Wheatstone bridge circuit. So this is the Wheatstone bridge, and Wheatstone bridge, in this Wheatstone bridge we need to check is it balanced or unbalanced, and the condition is for balancing P by Q is equal to R by S. If it is P, it is Q, it is R, it is S. P by Q is equal to R by S. If both are equal, then it is called balanced circuit. So at the place of P 1, at the place of Q is 2, at the place of R is 2, at the place of S is 4, 1 by 2 is equal to 1 by 2. This is we get. At this case, the potential balanced at these 2 points. So if potential is balanced means no current is flows through this, for example here in this 5 ohm resistance. So no current is flows through this 5 ohm resistance. That is why we cannot consider this resistor. So potential balance means if we need to current to flow, potential difference is must. So here the potential at this and this point, potential is balanced, so no current is flows. So at the same time, this is the another circuit. At the place of P is 1, Q is 2, this is P, Q, R, S. We need to check is it balanced or unbalanced. That is P by Q is equal to R by S. This is the condition. At the place of P is 1, at the place of Q is 2, at the place of R is 4, at the place of S is 2. So this is 1 by 2 not equal to 2. So this is unbalanced Wheatstone bridge, and we need to calculate resistance across these two, A and B. If it is balanced, in the balanced case, these two are the resistors in series, these two are the resistors in series, so that is 1 into 2. The circuit can be redrawn like this after solving. That is 1 into 2, 1 plus 2, 3 ohm, 2 plus 4, 6 ohm, and these two are parallel. So the resultant resistance is 3 into 6 by 3 plus 6, 9, 3 times. So the equivalent resistance across these two, A and B, is 2 ohm. And at the case of unbalanced circuit, we use another method. Actually, we need to do applying Kirchhoff voltage law, but in the case it is very it takes more time. Because of that, we need to use another method called star delta method. So star delta method. So how to solve? So this is the Wheatstone bridge, what they given, and in between these three resistors, that is like a delta, we draw a star, and like R1 and R2 and R3, these resistors, the combination called star delta. So R1 is, we need to calculate R1. For that, R1 left and right hand side for R1 1, right hand side 2, 1 into 2, sum of these three, that is 1 plus 2 plus 5. So after calculation we get 2 by 8 ohm resistance. At the same time, this is for R1. For R2, this is R2. For R2, that is 1 into 5 by 1 plus 2 plus 5, left and right hand side. For R3, the left hand side is 2, right hand side is 5. 2 into 5 by 1 plus 2 plus 5. After solving, we get 2 by 8, 5 by 8, 10 by 8. These are the values of R1 and R2 and R3. So the circuit redrawn like this. After solved, we can redraw like this. This is R1 and at the place of R2 at the place of R3. So this is the circuit I redrawn, and these two and R2 and R4 series, and at the same time R2 R3 and 2 is series. So we get 5 by 8 at the place of R2. We get 5 by we get 5 by 8 at the place of R1 is 2 by 8, 5 by 8, 10 by 8. R1 is R1 is 2 by 8 ohm, R2 is 5 by 8 ohm, R3 is 10 by 8 ohm. These are the three resistors. And R2 plus 4, we get at the place of R2 is 5 by 8 plus 4. After solved, we get 4.625, and R3 plus 2 ohm, 10 by 8 plus 2, that is 26 by 8, we get 3.25. So again the circuit redrawn like this. The resultant of these two resistors, we get 4.625 and 3.25. The resultant of these three R3 and 2, 3.25, and it is 2 by 8. It is 2 by 8. It is 4.625. It is 3.25 ohm. So these two are parallel. So for that parallel combination, we know the formula of parallel combination: 4.625 plus 3.25 by R1 R2 by R1 plus R2. We get exactly 1.9, approximately 2 ohm. It is depends upon what given in the options. What they given in the options, it is depend upon either approximate values or we need to take a exact value. It is depend upon the options. And at the place of 2 by 8, 1 by 4, that is 2 8 4 times, and 2 ohm, I am taken 2 ohm. So these two are in series. After solving, we get 2.25 ohm. Okay, thank you.